Hi Rockridge, this is Mrs. Berger, and today we will be starting day 1 of Unit 6. Unit 6 is all about rationals, rational expressions, rational equations, rational graphs. And what we mean by rational is, remember what a rational number was. Remember rationals, remember when we had that on day 1, reals and rationals and complexes? Rationals were things that could be displayed or expressed as a fraction. That's a rational. That's a rational. A lot of times in this unit, though, instead of having only numbers, we will have variables in the denominator in that fraction, okay? And so that's why this entire unit is about rationals. Today we will kick off rationals talking about rational expressions. We will simplify those expressions, we will multiply those expressions, and we will divide. So let's start by talking about simplifying rational expressions, what the goal is. We want to always simplify by making sure that the simplest form is as canceled out as possible, I guess is the way to say it. A rational is in simplest form when its numerator and denominator have no common factors. Okay, so we've canceled everything we can. A special note when we're dealing with rationals is to remember that we can't divide by 0. And because we can't divide by 0, and because we often have variables or x's in the denominator, we have to always take a look at the domain and make sure that we've accounted for things that we're not allowed to have that would cause a 0. That was a lot of words. Let's see if we can look at an example and see if we can make sense of this. So for example, number 1. Simplify this rational expression and state the domain. To simplify, we need to make sure that there are not any common factors on the top and the bottom. If there are, we need to pull them out and cancel them. The best way to do this is to factor. Look for factors. In the first problem, the numerator does not have any common factors, so there isn't anything to do on the top. But on the bottom, there is a common factor. There's a common factor of 2, and it leaves behind 2x minus 3. Now that we've done factoring, we see that there is a common factor besides 1 that is on top and bottom, 2x minus 3. We can cancel that because 2x minus 3 over 2x minus 3 is just 1. Same as 2 over 2 is just 1. We can cancel that and make it 1. Here, we cancel those things, and we make it 1 over 1, and leave ourselves with 1 over 2 as our simplest form of this rational expression. And remember, rational expressions are things without equal signs, right? If it had an equal sign, we would be looking at an equation. That's not today's lesson. Today we've just got a rational expression, no equal signs. Now, for the domain statement, we need to go back and look at the denominator and make sure that there's no way we could possibly ever divide by 0, because that's a no-no. And there are certain values of x that would cause division by 0, and we just need to make sure that that never happens. So if we look at the denominator, let's go back and look at the original denominator for simplicity's sake. There is a value of x that would cause a division by 0. 4x minus 6 is not allowed to be 0. Or 4x is not allowed to be 6. I added 6 to both sides. Or x is not allowed to be 6 over 4, which is the same thing as 3 halves. So the domain is x is not allowed to be 3 halves. That's a 3, sorry. X can be anything else in the whole wide world except 3 halves. If x was 3 halves, this expression would be dividing by 0, and that's a no-no. Now you might be saying, yeah, but the answer doesn't have any x's in it. The answer doesn't have any x's in it. There's no way I could divide by 0. 1/2 is 1/2. You're never dividing by 0. This is true. But if at any point during solving you could divide by 0, we need to make sure that we eliminate that value from our domain. So we can say number 1, can be simplified, and that x can be anything you want except 3/2. Let's take a look at number 2. Remember, our first step is to look at factors. So on the top, I do see common factors. I see 2x squared, and I'll leave behind x minus 4. On the bottom, I can factor that as well. Call back to your factoring knowledge from previous units. Something squared minus something squared, that's a difference of squares. In order to factor this difference of squares in the form a squared minus b squared, remember the factors of that are a plus b and a minus b. So for us, x plus 4 and x minus 4. Now remember, the goal of simplifying is to remove any common factors that are in the numerator and the denominator. And I see that x minus 4 and x minus 4 is common to both the top and bottom. So this leaves us with 2x squared over x plus 4 as the simplified expression. The original expression has been simplified. I absolutely love this day of notes because when we ask you to simplify, it actually ends up being simpler than where you started. So that's just my favorite thing. Now we need to go back and take a look at the domain. Step 2 is always to go back and look at what are the domain limitations of this. What are the values of x that at any step of this problem would have caused trouble for us because we'd be dividing by 0? Now remember, I don't need to look at the numerator to look for these values, the domain limitations or restrictions. I only need to look at the denominator. And at this stage of simplification, it was very clear to me that x plus 4 can never equal 0, and x minus 4 can never equal 0. Therefore, x cannot equal negative 4, and x cannot equal 4. Because if that was the case, if I had entered those values here for x, I would have been dividing by 0, and that's trouble. So the domain is everything. X can be anything in the world except negative 4 and 4. That's simplifying rational expressions. Now let's take a look at multiplying rational expressions. It's very similar to simplifying. Remember that if you're multiplying rational expressions, let's go back to the world of multiplying fractions. 1 over 2 times 1 over 3. Remember, in order to multiply fractions, you multiply top times top and bottom times bottom, right? The same is true here, except when you're multiplying tops and bottoms, you want to make sure that you simplify as you go along, because we don't want to have these answers be more complex or more complicated than they have to be, right? So we not only want to multiply, but we also want to simplify sort of at the same time. So again, we need to start by factoring, then state the domain, and ensure that we do canceling. Okay, because we want our answer in simplest form. Now this first one is not quite there's not much to factor here. You're presented with simply numbers and variables here, but it's a good way to demonstrate how we would do our canceling steps. Now instead of multiplying 12 times 2 on the top and making that 24x cubed y squared, I've already got things in nice little factored form almost. So I'm going to do my canceling right off the bat instead of multiplying things out and canceling later. I'll do both ways, but this is the way I would prefer to do it. Instead of making big giant numbers that I need to find factors of, I can see clearly that 3 and 12 have a common factor. I can simplify that to 1 and 4. When you're multiplying, it doesn't matter which fraction it is, as long as you're looking at the top and bottom, you're allowed to cancel. And then also I see on the top and bottom that there is an x squared and an x squared, so we can cancel those to be 1 and 1. And I see that on the top I've got y times y, which is y squared, and on the bottom I have a y squared. So those get simplified. Now I have 8x over 5. 8x over 5. That is the simplified multiplication answer. And now I'll go back and look at the denominators and make sure that I don't cause any problems for myself with the denominators. So let's look first at x. I've got an x squared on the bottom. X squared cannot be equal to 0 or it will cause a problem. Well, in that case, x itself cannot be equal to 0. Also, I have a y squared on the bottom. That can't be equal to 0, and therefore y can't be equal to 0. So my domain is x cannot be equal to 0 and y cannot be equal to 0. Let's take a look at number 2. Number 2 is more typical of what you'll see in this unit. You've got some work to do first. You've got some factoring work to do. I would factor each section of this. So let me color code these so that we know what we're talking about. There's an orange, there's a blue, there's a purple, and there's a pink. So let's start with the orange. To factor this, I notice there's a GCF, there's a greatest common factor of 5, and I leave behind x minus 4. For the blue, again, I see a greatest common factor of 5, and I leave behind an x plus 3. For the purple, I see a greatest common factor of 2, and I leave behind an x plus 3. And for the pink, I don't see any way to factor this, so I simply have x minus 4. Now, instead of multiplying the top together and the bottom together, I'm first going to cancel to take away some of the work that I have to do. I will cancel 5 over 5, that's just 1 over 1. I'll cancel x minus 4 over x minus 4, that's just 1 over 1. And I'll cancel x plus 3 and x plus 3, that turns into 1 over 1. And so I'm left with 2 over 1. I'm not even going to bother writing that, I'm just going to write 2. That is the simplest form of this expression. Now you see why I love this lesson so much. Look at how complicated it was when we started, and when we simplified, it got down to this gorgeous little 2. Now I do need to go back and check to see what troublemakers x might ever be. I'm going to look in the denominators at this stage, because those are the clearest. I know that x plus 3 can never equal 0, and I know that x minus 4 can never equal 0. Therefore, x can never equal negative 3, that would be trouble for us, and x cannot equal 4, that would cause trouble for us, that would cause division by 0. Therefore, x cannot equal negative 3 or 4, but you could have any other x value in this expression and we would be fine. Question number 3, again, factor and cancel. Let's color code again. We have the orange, the blue, the purple, and the pink. Now for the orange, we know that there is a greatest common factor of x, and so we'll pull that out and leave behind x minus 2. And then for the blue, we take a look and see that there is some typical factoring that we needed to do, just like our quadratics unit. There is not a GCF. There's not something common to every single term. We need to find, in this particular case, this trinomial. To factor this trinomial, we need to remember what multiplies to 1 and adds to 2. Hopefully you came up with x plus 1 and x plus 1. For the purple, once again, we have a trinomial. We need to find what multiplies to 3 and adds to 4. Hopefully you came up with x plus 1 and x plus 3. And then for the pink, we don't have a trinomial, we have a binomial, and it appears we have a greatest common factor of x, and we'll leave behind x plus 3. Now we can cancel. X plus 1 and x plus 1 turn into 1 over 1. X plus 3 and x plus 3 turns into 1 over 1. X and x turns into 1 over 1. And there's nothing else to cancel, so I'll take what's left and state that the simplest form of this is x minus 2 over x plus 1. That is the simplified form of this multiplication problem. Now we'll need to check for domain limitations. And remember, domain limitations can happen at any point along the solving, so we need to account for all of them. So let's make a list of all the different things that we see on the bottom and say that each of those factors can never be equal to 0. X plus 1, you may not equal 0. And I don't need to write that twice. So then I'll write x, u may not equal 0, and x plus 3, u may not equal 0. Those are all the different ways that we could cause problems if there was 0 in the denominator. Therefore, x does not equal to negative 1. This is already as simple, isolated as it can get. And x cannot equal negative 3. So our domain is x does not equal negative 3, negative 1, or 0. Any other value of x would be fine, and the top never causes a problem. Having a 0 on the top is not a problem. Only having a 0 on the bottom would be a problem. Go ahead and pause the video or grab those notes. I need to wipe the board so I can start the next question. Now, question number 4. We love this one. It has a cute little trick to it that you'll use constantly. Hopefully you see that multiplying these two fractions together, it screams canceling the 3 over 3, right? You're so excited. I know, you want to cancel that 3 over 3 and make it a 1 over 1. We are going to do that. But also, 12 minus x and x minus 12. We know that it looks real close to each other, but they're not exactly the same, and we're not allowed to cancel things that aren't exactly the same. Well, let me show you what these are the same as. Notice that if we were to rewrite this as negative x plus 12 over 3 times x minus 12 over 3, oh sorry, other way, 3 over x minus 12, we once again get real close to what we need. But also take a look at this. If we pull a GCF of negative 1 out from that top left corner, if we pull a GCF of negative 1, we will leave behind x minus 12. And once we have that, we see what we can cancel. You will always need to identify this capability here of taking out a negative 1 so that you can cancel completely. If you don't do that and you leave behind an answer of 12 minus x over x minus 12, it is not in complete simplest form and you will lose credit. So make sure that you're able to recognize when you have this opportunity. Now, let's cancel. 3 over 3 turns into 1 over 1. X minus 12 over x minus 12 turns into 1 over 1. And so the final answer is negative 1. Negative 1 over 1, but negative 1 nonetheless. Now, we definitely have some domain restrictions that we need to state. Troublemaker x comes from x minus 12 may not equal to 0, and therefore x may not equal positive 12. So our domain restriction is x may not equal 12, but it can be anything else in the world. Let's take a look at one more multiplication question. It might be helpful if you pause the video and try this on your own so that you can get some practice on your own. If you want to follow along with me, that's fine. I will factor fairly quickly for this though, so if you want to pause and try it on your own, please do so. So once again, I will color code each section so that we know what we're talking about. And for the orange section, I notice that it is a difference of squares. And so the factorization of that a squared minus b squared scenario is 5 plus 2x and 5 minus 2x. Underneath there, I notice that there is a GCF. There's a GCF of 3, so I'll pull that out and leave behind 2x squared plus 3x minus 5. I'll need to continue factoring that, but for right now I'll leave it like that and continue to the next spot. In my purple section, I again have a GCF, so I'll pull that out and see what gets left behind. I'll pull the 2 out and leave behind 3x squared minus x minus 2. And then down below in the pink section, there's no GCF, but I can certainly start factoring that. Factorization of 2x squared minus x minus 10. Now, back in the factoring unit, we had 3 or 4 different ways that we could look at how to factor that 2x squared minus x minus 10. Some of us tried to find what multiplied to negative 20, added to negative 1, and then did the t-chart with the 2's on top. Some of us split the middle. Some of us guessed and checked. Some of us did slide and divide. Okay. In any case, I'm going to do negative 5 and 4. In any case, you should end up with a factorization of 2x minus 5 and x plus 2. 2x minus 5 and x plus 2. So however you did factoring, those are the steps that you're going to need to take. And we'll leave you enough room when you have a quiz or a test to do that factoring work off to the side. For right now, I'm going to clear that out of my way. Now, with the orange and the pink, we have gotten this as factored as much as possible. With the purple and the blue, we've got some more factoring to do. So again, depending on what your favorite method of factoring is, you're going to want to go ahead and use that method to go off to the side and factor the blue and factor the purple. Okay, so we still have the orange as is. And to save some time on the video, I'll go ahead and tell you what the factorization of the blue is. We know that it's 2x and x here, and we know it's some version of 5 and 1 at the ends. It's plus 5 and minus 1. And then for the purple, we'll do the same thing. We still have this 2 out front, and then what multiplies to negative 6 adds to negative 1, and then you have to simplify that further. So we have 2 times x minus 1 and 3x plus 2. And then on the pink, we didn't have to do any more work. 2x minus 5 and x plus 2. Now, we definitely want to start canceling where we can. Keep a sharp eye out for things that are the same, and they have to be exactly the same signs. So hopefully you see that the x minus 1 and x minus 1 cancel. And I know it's not very, very obvious, but this 2x plus 5 and this 5 plus 2x are actually the same thing, right? They're just in a different order. So those are actually the same thing, so those cancel to 1 over 1. And then what did we just learn in the last problem about 2x minus 5 and 5 minus 2x? We can factor out a negative 1 and leave behind a 2x minus 5 here that does in fact get canceled. So if we replace that with negative 1 outside of 2x minus 5, that and that cancel to 1 over 1. So we leave behind 1 times negative 1 times 1 times 2 times 1 times 3x plus 2. So we leave behind negative 1 times 2 times 3x plus 2. And on the bottom, we leave behind 3 times x plus 2. A little more simply, we can say negative 2 times 3x plus 2 over 3 times x plus 2. That's the simplified form of the multiplication problem that we were presented. And yes, it's a lot of factoring. Some of us can do the factoring in our heads. Some of us need to jot it off to the side. We'll give you enough room to work to make that factoring happen. Just make sure that you understand how those trinomials were factored, how those differences of squares were factored. Now let's go back and look at where we could have had problems with x values causing a 0 in the denominator. I will go look at all the different factors when we had them finally factored, and notice that all of those things cannot equal 0. 2x minus 5 cannot be 0, and then x plus 2 cannot be equal to 0. So those are all the things that could cause trouble. Therefore, x cannot equal negative 5 halves, x cannot equal 1, x cannot equal positive 5 halves, and x cannot equal -2. So my domain, I will state, is x cannot equal positive and -5/2, 1, and -2. And this right here is our simplified form of that multiplication problem. Alright, if you need a pause, now would be a good time to take a little bit of a brain break. We're about to do our last part of our lesson, and that is dividing rational expressions. So dividing rational expressions, if you recall, when you had fractions like 1/2 divided by 1/4, do you remember what you had to do in earlier grades of math? Hopefully you recall that you needed to take 1/2 and multiply by 4/1. And then certainly we want to make sure that we cancel this 2 and that 4, so that 1/2 divided by 1/4 is equal to 2, which makes sense. There are 2/4 and a half. So the same process will apply to rational expressions. When we have rational expressions that need to be divided, yes, indeed, we need to multiply by the reciprocal. So we will need to flip the second fraction, or whatever fraction comes right after the division sign, and we'll need to factor, and we'll need to look at the domain, and we'll need to cancel. Okay. So for this first one, once again, we don't have to do a whole lot of factoring. We're just practicing this flipping and canceling step. And so let's write this as 5x to the 5th over 8 times 12 over 15x squared. And now we can start canceling. The 12 and the 8 turn into a 3 and a 2. The 5 and the 15 turn into a 3 and a 1. This 3 and 3 can turn into a 1 and a 1. The x squared and x to the 5th, remember that x to the 5th on top and x squared on the bottom leaves x to the 3rd on top. So this makes this turn into a 3. So our simplified expression is 1 times x to the 3rd over 2. That is the simplified version of that division problem. And now we'll go back and see, is there anywhere we could possibly cause a problem with a value of x? This denominator right here has variables in it. Now, this denominator here is not a problem. That 8 is not a problem. 8 is always 8. It's never going to be 0. But 15x squared could be a problem. If x was ever 0, that would be a problem, right? Because you'd be multiplying 15 by 0, and all of a sudden you've got a fraction trying to divide by 0. So x cannot be 0, and that is the only thing we need to care for this particular problem. All right, number 2, we're back into factoring land. We're looking for GCFs, we're factoring trinomials, and that type of thing. Also, we need to recall that when we divide, we need to multiply by the reciprocal. So let's start that now. In the upper left, it looks like I have a GCF of 2x squared, and I'll leave behind x minus 6. Underneath that, I've got a trinomial that needs to be factored. The things that multiply to -12 and add to -4 are probably some version of 6 and 2, not 4 and 2. 6 and 2. And we know that the 6 must be negative and the 2 must be positive. Now, I am going to flip the fraction here. And we'll move this purple to the bottom. And we'll move the pink to the top. And we'll factor those in a moment so that we can see if there's anything that cancels. So go ahead and copy your blue and your orange down, because we're not going to do anything with them just yet. And now we need to look at what multiplies to 18 and adds to 9. Hopefully you thought 6 and 3, both of them positive. And then on the purple, we have a binomial, not a trinomial, and it appears we have a GCF of 8x squared, and so we'll leave behind an x plus 3. So to finalize the simplification steps, we will go ahead and cross out the x minus 6 over x minus 6, and we'll cross out the x plus 3 over x plus 3, and the x squared and the x squared, and the 2 and the 8 leaves behind a 4. So the simplest form of this is x plus 6 on the top, and 4 times x plus 2 on the bottom. Now, one of the big things that a lot of people forget is that you may not pull out a 2 from the 6 and the 2. Remember that unless you can factor something out here and cancel it with the 4, you may not do any more canceling at this step. Okay? So x plus 6 over 4 times x plus 2 is your final simplified answer to this division problem. Now, domain. We have got to go back and look at all the different things that could have caused us a problem. So for the blue, we could have had an x minus 6, that's not allowed to be 0. An x plus 2 is not allowed to be 0. And for the purple, we know that x squared cannot be equal to 0. And we knew that x plus 3 cannot be equal to 0, so we've got to account for that. And then also remember, the pink used to be on the bottom. So the pink stuff's not what it could have caused a problem originally. So all of the pink factors are not allowed to be equal to 0 either. X plus 6, you're not allowed to be equal to 0. And x plus 3, you're not allowed to be equal to 0. We already had that one, though, actually, right there. So we actually didn't need to rewrite that one. So now let's state our domain limitations. I'm going to jot these over here in colors. So x, you may not be equal to 0, negative 3, you can't be equal to 6, or negative 2, or negative 6. All right. So we have 3 more division problems. I'm going to work on number 3 with you, and I encourage you to pause the video and try number 4 on your own. So let's look at number 3. Number 3 currently has x cubed minus 8 sitting over top of 1, so keep that in mind for when you're flipping. Let's take a look at the first fraction and do some factoring before we start moving things around. So what multiplies to 2 and adds to negative 3? Hopefully you thought x to the x minus 1 and x minus 2. And then on the bottom, we don't really have anything to do there, nothing to factor out, it's just simply one term. And I'm going to go ahead and flip. So instead of x cubed minus 8, I'm going to have x cubed minus 8 over 1, I'm going to have 1 over x cubed minus 8. Now, x cubed minus 8. Hopefully, this is keying in your mind difference of cubes. Do you remember the factors of a difference of cubes? You need to be able to recognize that it is a difference of cubes, as well as what the factorization of that is. Now, for purposes of just saving space, I'm going to just rewrite this difference of cubes in its factored form right here. Here's how we do it. X minus 2, x squared, plus 2x, plus 4. Remember? A cubed minus b cubed. SOAP took care of our signs. And this is a minus b. This is a squared plus ab plus b squared. Right? Please have that in your mind. You still need to remember that for these. Alright, now let's start canceling where we can. I don't know that there's a whole lot we can cancel. Certainly the x minus 2 and x minus 2. This is prime. There's no more factoring of that. So when we give you that formula for factoring a difference of cubes or a sum of cubes, we've given you 2 prime factors. There's no more factorization of that. And so there's nothing else to cancel. So our final answer for this is x minus 1 over 4x squared times x squared plus 2x plus 4. So that's the answer to that division problem, completely simplified. And now what we'll need to do is state our domain. We need to look for all the different values of the domain that will be troublemakers. I'm going to look at the blue and notice that x squared cannot be equal to 0, so x can't be the 0. I'm going to look at the maroon and say x minus 2, you're not allowed to be equal to 0, so x, you're not allowed to be equal to 2. So that's how I'll state my domain. X, you're not allowed to be equal to 0 or 2. Now, number 4 is definitely challenging, but I highly encourage you to pause the video right now. I'm not going to work through it. I'll show my work in a minute. I'm not going to work through it live through the video. Please pause the video and try it, and then check your answer in a moment. Okay, so many things going on here. I haven't quite gotten to my final simplified answer, but hopefully you got this far in your factoring. I've got the factoring work off to the sides if you needed to check your work. And I've definitely factored out some GCFs of -1 to make my life a little bit easier. So in the orange, that's the first thing I did. In the blue, I got tempted because I saw that x minus 3 up there, and so in the blue, I took a -1 out of there as well. So here's what we're going to do. We're going to cancel as much as we can. I see x plus 3 and x plus 3. I see x minus 3 and x minus 3. I see -1 and -1. And those 2x plus 5s are right next to each other. Those cannot be canceled. So they're on the same level there. So you have 2x plus 5 squared. If you wanted to write them twice, that's fine as well. And on the bottom you have 4x plus 1. So that's your final answer to that division problem. And those factoring the -1s out were definitely your last little key. Factoring the -1 out, that only comes after you've been able to factor those trinomials using your x and your t-chart or your slide and divide work. So please, please, if you need a reminder on how to factor, go pull that factoring tutorial video up. Now let's real quick go check for troublemakers. In the blue, we've got a couple of different troublemakers in the blue. 3 plus x cannot equal 0. 3 minus x cannot equal 0. In the purple, 4x plus 1 cannot equal 0. And back originally in the green, when they were on the bottom, 2x plus 5 cannot equal 0, and x plus 3 cannot equal 0. So we'll need to account for all of these domain limitations. And actually that one that I just wrote in the pink is just a duplicate of a blue, so I'm not even going to bother redoing that one. So my x's cannot be -3 or 3 or -1/4 or -5/2. So make sure you have all of those. And we'll try our last division problem before we set you on your way with your homework. Alright, now this one is just to remind us that the division, the flipping, only happens in the fraction that comes right after the division sign. So do not flip this guy. That guy stays the way it is. But this whole fraction gets flipped because it comes right after the division sign. So let's take a look at this guy and remember that that's over 1. And I am going to factor as I go along as much as possible. So if I'm looking at this first fraction, the factored form of x squared plus x minus 30, so that what multiplies to -30 and adds to 1. And then let's go ahead and flip and then factor later. Let's go ahead and do this like this. So let's flip it to be x squared plus 7x plus 12. And x squared minus 11x plus 30. So that's the flipping step, that's complete. And then of course, x minus 6 over x plus 6 stays the way it is because it came after a multiplication sign. Alright, let's do our last little bit of factoring. So x plus 6, x minus 5, we're just copying. Factoring the purple, multiplies to 12 and adds to 7. The pink multiplies to 30 and adds to -11. And then we still have our originals on that last fraction. Now we're ready for canceling. Remember, they have to match exactly. So x minus 5 and x minus 5 are fine. X plus 6 and x plus 6 are fine. X minus 6 and x minus 6 are fine. And I don't have anything left on the bottom, so whatever's left on top is what we're left with. And so our final simplified answer of this division problem is x plus 3 times x plus 4. Now we need to go back and check for our domain limitations. So we'll circle that as our answer. And then our domain troublemakers, there was nothing here. There's no way for 1 to ever equal 0 because it always equals 1. We definitely want to take care of the fact that x plus 6 is not allowed to be equal to 0. We want to take a look at the purple because it was originally on the bottom. So for the purple, x plus 3 cannot equal 0, and x plus 4 cannot equal 0. And then, of course, the pink ended up on the bottom. So x minus 5 cannot equal 0, and x minus 6 cannot equal 0. So we will state our domain as x cannot equal negative 6. It can't equal negative 3 or negative 4. And it can't equal 5 or positive 6. And you're more than welcome to put those in numerical order and combine or shorthand. That's our domain statement. Alright, you have a considerable amount of homework because we want you to practice as much as possible. You'll see so many versions of these. Good luck on your homework, and let us know if you have questions.